Remember yesterday we talked about volumes of prisms and cylinders, right? Prisms and cylinders, correct? Volume of a prism, length times width times height. Volume of a cylinder, pi times radius squared times height, correct? Okay. Today we're going to go with pyramids, cones, and spheres. Talk about how we compare these particular volumes of them, learn and apply the formulas, starting off with the volume of a pyramid. Okay, volume of a pyramid, guys, is closely related to the volume of a prism. Let's talk about it. All right, can everybody see this? Look at my figures here. Can everybody see how the base of this pyramid and the base of this cube are the same? Yeah. You'll see that? The two-dimensional bases are the same, right? But when I apply their height, it's different, right? Now let's just use some intuition here. Which one of these two would have the larger volume? The cube, right? Correct? Yeah, the cube would have the larger volume, and that's reflected in our formula, okay? Because our formula is 1/3 base times height. Okay? The volume of a pyramid has a formula that is 1/3 big base times height, where the big base is the area of, it's either going to be, I'll just tell you, it's either going to be a rectangle or a square. Okay? Got me? Great. There's nothing else it can be, actually. Okay? So you need to find length times width times height. You're basically doing the same thing, but this formula is taking 1/3 of that total volume. Okay? So you might get a question that says, how does this volume and this volume compare? Right? If it has the same area and it has the same height, think about it. Well, if it has the same area and height, that means that this particular, I'm going to use this one instead. It means that this particular volume is 3 times bigger than this one. Okay? Or this volume is 1/3 of this one. You got me on that one? Okay? Pretty straightforward. Let's apply it. Right? Find the volume of a rectangular pyramid with a length of 11, a width of 18, and a height of 23. I know it sounds weird. I want everybody to practice this with me. We're going to practice putting this in our calculator. Okay? So, get your calculators out. Hit the parentheses button. And you're going to put all of this in parentheses. I want you to put parentheses 1/3. And your calculators. Go parentheses 1/3. And then close your parentheses. And go parentheses 11 times 18. Close the parentheses. Parentheses 23. Close the parentheses. What do you get? 1518, correct? Okay? 1518. Right? So that way, when you get to your test, you know what you should do when you're putting all this in the calculator. Okay? What is our unit of measurement here? Meters what? Cubed, correct? We're still talking about cubic measurements. Okay? You got me? We've added another dimension with the height, so we're still talking about that. You guys do this one on your own. I'll give you 30 seconds. We know that it is 1/3 big B times H. How do we find that? We got 9 times 9, right? When we talk about big base, we're talking about finding the area of this base, right? Is this a square? It is. So you could take 1/3, 9 times 9, or 9 squared. What's the height here? 14, right? Guys, put all that in parentheses, you're rolling. What'd you get? 378. Okay? So far, so good, right? Everybody with me on that? Okay. We come to this. We say, oh, now I want a cone. Let's see. Put on your thinking caps. What's the difference between this and this? A circle, right? They both have pointy tops, correct? Okay, both have pointy tops. But if you calculate the area of the big base here, you're talking about the area of the circle, okay? Same formula, 1/3 big base times height, but in this particular instance, pi radius squared is how you'll find the big base. With me on that? Okay, so 1/3 big B times H is still the formula, but in this instance, you might as well just get ready because you're going to be using pi times radius squared to find your big B. Alright. What might this look like? Check it out. Find the volume of a cone with a radius of 7, a height of 15. Guys, 1/3 pi times 7 squared times 15. If you need to practice putting that in your calculator, do so. Put parentheses around 1/3. I would put parentheses around pi. Put parentheses around 7 squared. Put parentheses around 15. Any questions? Really straightforward, right? Looking scarred? Alright. Then we got one like this. I want to put a couple of these on there. Find the volume of a cone with a base circumference of 25 pi, a height 2 inches more than twice the radius. Oh, what's wrong, son? You gave me a Megan look. I want the Maddie look back. Alright? Never mind. Volume of a cone is what, guys? What's the formula? Perfect. Radius squared times height, correct? Well, this tells me that the circumference is 25 pi, right? If the circumference is 25, check this out. 2 times radius. Is that right? Is the circumference formula, is the circumference equal to pi times 2 times the radius? Look on your formula sheet. If you doubt me, it's on the left-hand side. It says circumference. It says 2 pi r, or pi times 2 times r, okay? Or pi times diameter. You with me? Check it out. I substitute 25 pi for C. 25 pi equals pi times 2 times radius. Let's divide. We're solving for r, so we're going to divide both sides by pi. 25 equals 2 times the radius. How do I solve for r now? Divide by 2. Solving for r. Half of 25 is 12.5, right? Okay, everybody with me on that? How do I find the height? The height is what? No, read the whole thing. Height is what? Alright, this is EOC. You're on, pretend like right now you are on the EOC. Okay? Your height, and you gotta read. I don't know what else to tell you. The height equals what? 2 inches more than. What does that mean? Write me an expression or solve it. Either one.
12.5 times 2 plus 2.
Say it again, homie.
12.5 times 2 plus 2.
Isn't that what you just said? Did you hear what he said? Twice the radius is 12.5 times 2, correct? 2 more than twice the radius is 12.5 times 2 plus 2, right? Y'all see that? Any questions about that? That's the type of question you're going to get on your EOC, okay? That type of stuff. 27 is the height because 12.5 times 2 plus 2. You want to put a little order of opposite in there, right? This is 25 plus 2. So your height is 27, correct? All right. Now you've got a radius and a height. Plug those in. When you plug them in, this is what we just did, right? We just did all this. So use the circumference to find the radius. Use the radius to find the height. Plug it in. 1/3 pi times 12.5 squared times 27 should get approximately 1406.25 pi, or 4,417.9. Yep. So, yeah.
How'd you get C equals pi times 2?
We're on the left-hand side of your formula sheet. Yep. You got to be able to piece all that together, okay? Y'all piece this together too. All right. Y'all gonna get mad at me. Lateral, what is the formula for the volume of a cone? Is this a cone?
Yes.
Yeah. Can you assume it's a cone if it says it's a cone?
Yeah.
You good? Okay. Go ahead. What you got?
1/3
1/3
pi
pi
radius squared
radius squared times height, correct? Justin, what's the radius here?
16.
16. Hey, David, what's the height here? Wrong. Anthony, what's the height here? Samantha, what's the height? Tyler, what's the height?
Wait. Is the 34, is that the side? Is that
The side.
Use the theorem to get that. Right?
Stole my thunder and about all of these people's good souls. So I was going to go through the whole class until somebody told me. Hear what he said? What do you have right here, guys? A what? What is that? What kind of triangle?
Right
It's
triangle.
a right triangle. This is the height, right? You got me? That's the height. This is the side. I know it's confusing, but that's the hypotenuse. Okay? So here's a leg, here is a leg. We're going to use Pythagorean theorem. X squared plus 16 squared equals 34 squared. X squared plus 256 was 34 squared. Hurry. 1156. Subtract 256. Go ahead. Hurry. Do what?
900.
Okay. How do I get rid of this power of 2? Bo, how do I get rid of this? Square root both sides. Do you know the square root of 900? Hey, you ready for this?
Yeah.
I'll show you a trick. You ready? What's the square root of 0?
0.
Good. What's the square root of this 0?
0.
What's the square root of 9?
3.
Okay. What happened to the first 0? It left. Alright. Height. Now I know height is 30. I can plug that back in. Alright, Anthony, way to pick that up. You guys see that, right? What you're going to do is you're just going to assume this is the height. You get this, though? You get where the figure would come in handy here? This is talking, 34 is talking about this, right? That's the side. That's not the height. The height goes straight up and down. I gotta use a pencil here. The pencil represents the height, right? This is the side of the cone, okay? Everybody with me on that? You see it once, you probably get it again. All right, we'll rush through this. A sphere is the locus of points in space that are a fixed distance from a given point called the center of a sphere. Duh. Don't worry about that. A radius of a sphere connects the center of the sphere to any point on the sphere. The hemisphere is half of the sphere. A great circle divides the sphere into 2 hemispheres. All right, I'm going to cut it down for you. Write down the definition of sphere and write down the definition of hemisphere, and that's all you got to worry about, okay? Hemisphere. I'll come back to you. All right, here we go. A sphere. You want an example of a sphere, maybe? Okay, I'll tell you an example of a sphere. This tennis ball, how about that? It's a sphere, right? Baseball, basketball, a soccer ball. Can anybody else think of anything else in the world that would be a sphere?
The world.
The world, yes. The earth.
No, he's
He's an idiot. All right, so he's probably not an idiot. He probably has some really, is Bailey Walker an idiot?
He can't really wax.
All right, so check this out. Check this out. A hemisphere and a cylinder with a cone removed from its interior. I got these figures. Hemisphere, cylinder, right? And in this particular cylinder, I've taken out this much of the cylinder, if you can imagine that, okay? So I removed that much. All right, the cross sections have the same area at every level, so the volumes are equal by Cavallari's principle. That's right, what's Cavallari's principle? We're revisiting this. If two figures have the same base area and the same height, they have to have the same volume. Okay? If two figures have the same base area and at every level they have the same height, they have to have the same volume. Right? I don't care what it looks like. If I took a cone out of this, and the cone, the cylinder, and the hemisphere have the same radius, and I set it at the same height, they have the same volume. Okay? That's Cavallari's principle again. I don't think I did too much of that for you today, but I did a little bit. The volume or the formula for the volume of a sphere is 4/3 pi radius cubed. Got me? This is the most missed thing in the whole unit. Do you guys see that the volume includes the cube? You're going to have to multiply radius times radius times radius. Right? Got me? You multiply radius times radius times radius. 4/3 pi times radius cubed. Alright? Y'all hear me? You're not talking about a circle. A circle, pi r squared, right? You're talking about a whole sphere. So you take how you would get the circle, pi r squared, and you're adding another dimension to it. I can't really do anything except show you with my tennis ball. Pi r squared would only give you the base area of the circle, right? But when you add another height dimension, it's like you're adding another radius level to it, okay? All right? 4/3 pi r cubed. All right, here we go. I haven't called on anybody over here in a while. Randy, you're on your phone. Randy, what is the radius of this particular sphere? Good. Radius is 12. Randy, what is the formula for the volume of a sphere? Okay, 4/3 times pi times radius cubed. Mr. Hobbs, is it as simple as putting 4/3 pi and then radius cubed into my calculator? Yes, it is. Okay? If you need to know how to find cubed, right next to x squared, you see a button on your calculator, and it says x, and it has a box with it. Woo, disaster. Okay, it has a little box with it. You can hit that button and put a 3 in there, okay? Or you could hit shift that 2. Okay? What'd you get? 7234.5? Something around that area? Let's see here. Inches what? Cubed. Okay? Inches cubed. Okay? This is the tough one. I'm going to go over this one with you guys. You need to take good notes on it. This was on the EOC 2 years ago. Y'all with me? This was on the EOC 2 years ago. If you want to know the type of question you might get on the EOC, I think it's tough. Here's the type of question you're going to get. Y'all with me? Find the diameter of a sphere with a volume of 36,000 cubic centimeters. All right, we have a starting point. Starting point is our formula. 4/3 pi radius cubed. We plug in 36,000 pi for the volume because it says the volume's 36,000 pi, right? You with me on that? All right. If I want to find the diameter, what's the relationship between diameter and radius? Okay. Radius is half the diameter, right? So if I solve for a radius and multiply it by 2, in effect, I'm solving for the diameter, right? Let's solve for r in this equation. Divide both sides by pi. You got me? Dividing both sides by pi. I get rid of pi altogether. Okay? I get 36,000. Mr. Estevanco, I highly suggest you take notes on this. $36,000 equals 4/3 radius cubed. How do I get rid of that fraction? You can divide, and I'm not going to count it wrong if you divide. But if you divide, you better make sure that you get those next steps right. I cut the chase. What you do? Do what? Well, you can't put in a whole number because you don't have a decimal with it. Can you change it to a decimal? Again, you can. Okay, you can, and it's not wrong if you do it that way. It's not the way I want it. I'm going to teach you, but it's not wrong. Okay. All right, here we go. I multiply both sides by the reciprocal. I multiply both sides by the reciprocal fraction. I did this in first block and it may have been helpful. Maybe. Why, Mr. Hobbs, do you multiply by the reciprocal? It goes all the way back to your fraction rules. You guys remember when you multiply fractions, you multiply straight across? Does anybody remember that? Does everybody remember that? Right? You just multiply straight across, right? Traylon's shaking his head. Traylon, what's 4 times 3? What's 3 times 4? What is the fraction 12/12 simplified to? 1. Got me? So when I multiply the fraction by the reciprocal, I get 1 here, and everything cancels out. Okay? And if the object is to get r cubed by itself, I've achieved that in one simple step. You'll see that? I mean, it's just a technique. I think it's the easiest one if you remember how to do it. What about over here, Mr. Hobbs? Well, you have these beautiful things called calculators. Literally, all you have to do is type 3/4 and 3 times 36,000. What'd you get, Scarborough? 27,000, right? 27,000 equals r cubed. Okay? I multiplied both sides by 3/4. It wipes out the fraction on the right side, and in the left side, I multiply this, and 3/4 of 36,000 is 27,000. 3/4 times 36,000 is 27,000. You can type that in your calculator. All right? That was step 1, big step 1. Yes, sir. If it's in this answer. If pi is not in this answer, whew, whole different way to solve it. Okay? Alright? But 99 times out of 100, they're going to give you pi in the answer. Okay? Go with me? Alright. I think I've got you ready for Coach Young and 11th grade math, but we'll see. If I had a 2 right here, how would I get rid of the 2? Square root. I got a 3 right here. How do I get rid of the 3? Cube root. Okay? You take the 3rd root. You understand when we say square root, that means you take the 2nd root of the number, right? Well, if you got a 3, you're going to take the 3rd root, okay? It's known as the cubed root. So the 3rd root will eliminate the power of 3. It gets r by itself. In your calculator, do you guys know how to do that? Okay. As long as you know how to do that, you can hit shift square root if you don't. And you get 30. Whoa, time out. You did all this work, it's right. Get the question right. What's the question that was asked? How do I find the diameter? Take your radius, multiply it by 2, you get a diameter. Okay? Alright. Hopefully you see, guys. Very doable. You do it about 3 times today, I promise you, you'll be ready. Okay? Got me? You just got to go through that method about 3 times. You're going to be ready for Friday. Alright. Last thing. The last thing. This says find the volume of a hemisphere. It gives you a whole new question. Don't worry about that. Alright? Guys, here's how you find the volume of a hemisphere. Find the volume of the sphere and divide by 2. Got me? Find the volume of the sphere and divide by 2. You can use this, but this is a whole nother formula that you got to learn, and it's not on your formula sheet. Right? So I'm telling you, what does Hemi mean? Half. The 2, half, right? Half. That's simple. Find the volume of the whole sphere, cut it in half by dividing by 2. Okay? Last thing, it says find the volume of the composite figure. I want you to see what this is. This is a hemisphere, right? Inside of a cylinder. Okay? It's a hemisphere inside of a cylinder. Watch what happens here. This is, yesterday we did composite figures and I said, all right, hey, they stack on top of each other, right?
Yeah.
Got me? Now all of a sudden, I can't get the top off of this. Now all of a sudden they've stuffed the hemisphere inside, right? Let's use our noggins on this. If I said find the composite figure of this, you would find the volume of the cylinder, you'd find the volume of the hemisphere, and you would do what with them? Add them together. If I stuff it inside, what do you think you're going to do with the volumes? Subtract them, right? You're going to subtract the volume of the hemisphere from the volume of the cylinder. Okay? Right? Subtract it. You subtract it out. Imagine it's hollow in there and you got to take it out, right? Am I with me on that? Okay.